Just to get started here, my name is Kyle Meggs, and I'm one of the product managers for Cloud Memorystore. With me today is Matt Geerling, another product manager for Google Cloud Memorystore. And joining us in a few minutes is Animesh from Palo Alto Networks, who's a distinguished engineer.
So let's start by talking about the agenda we're going to talk through today. So first, we'll start with the Memorystore service as a whole. We'll go over some overviews, service that exists today. Then we're going to talk about our brand new Redis cluster launch. Highlighted that in green because we're super excited about that. We had a launch blog go out yesterday that you might have seen. Then Animesh is going to talk about Palo Alto Networks' use of Memorystore in their Cortex Data Lake application, which is a huge scale security data processing app. We're talking trillions of events per day at petabyte scale. And then we'll go into closing.
You may have seen this slide before if you've attended other database sessions, but this is an overview of our portfolio. On the left there, you see Memorystore in blue. This is a managed service for Redis and Memcached. Customers love Memorystore for three main reasons. One is that it is a managed service, so you don't have to be a Redis expert. You don't have to be a Memcached expert. You don't have to worry about, is my replica in the same zone as my primary? We handle all of that for you, so it makes a lot of things simpler. The second is that it has predictable low latency, so you can rely on that low latency building your applications, potentially downsize the compute required for your database behind Memorystore. And the third is that when you do that, you can actually save money. So we're going to talk to Animesh about how Palo Alto Networks uses Memorystore to downsize their Cloud SQL and actually saves money overall and improves the speed of their application, which is pretty great. Memorystore provides microseconds latency and is already used by over 90% of the top 100 Google Cloud customers. I have a couple example use cases here on the right. The most common one you're probably familiar with is just a simple cache. So putting Memorystore in front of your persistent database so that when you fetch data, first you go to Memorystore. If it's there, you're going to get it with this ultra-low latency. If it's not there, then you go to the database. It's going to be higher latency. You can then populate Memorystore, so the next time you need that data, you can fetch it with that ultra-low latency. So that's kind of the biggest use case. We also have Session Store here, so imagine you're a retailer and you're doing an online checkout. We want to keep that user's session data in memory so we can access it with super low latency and give a really nice user experience. Third, I'll mention leaderboards. So, obvious for gaming companies, you want to have leaderboards. You want to take advantage of Redis sorted sets, and you get these nice data structures to make this all really easy. Or maybe you're a fintech company and you're showing stock tickers at the top of the page. Again, leaderboards just makes this super easy. And because all this is so easy with Redis, it has become the most popular in Memorystore. So you can see over time, Redis has only grown in popularity because it is fast, versatile, it offers high availability, and developers have just come to love it. So we're excited today to talk about Memorystore for Redis cluster because we think it's going to take Memorystore to the next level.
So let's start and talk about the Memorystore for Redis service that has existed. If you're on the platform today, you may already be familiar with this. Memorystore for Redis that we have today is fully managed. This means no need to worry about the underlying infrastructure. You just say that you want to cache and we'll give it to you. Memorystore for Redis is also highly available. You can scale horizontally with up to 5 read replicas. With these 5 read replicas, you can support north of 1 million read requests per second with a single instance. In addition to this, it is vertically scalable while online, so you can resize your cache to meet your data needs, going larger or smaller as needed. In addition to this, we are offering an integrated database maintenance experience. We will handle patching for you. We do that in a rolling upgrade fashion. We're integrated with the maintenance window framework that you might be familiar with that other GCP services use. We are integrated with cloud monitoring. There is rich metric support so that you can monitor the health of your instance. You can also export that to whatever monitoring solutions you might be using today. We've optimized open source Redis and added improvements such as better failover, as well as added memory protection for your instance when you're nearing memory exhaustion. And then finally, we are backed by the same 24/7 Google Cloud support that you're already used to. So that was Memorystore for Redis service as it has existed. Let's talk about some of the recent launches. The focal point of today's conversation is the Memorystore for Redis cluster launch. So this is a new service that supports the open source Redis cluster protocol. You can horizontally scale now, so no longer are you working with these single node Memorystore deployments, single node Redis deployments where you have to replicate the entire data space to every node. Now you're horizontally scaling and sharding out this key space so that you can reach a much larger scale. In addition to that, a few other launches we've had this year. CUDs, these are committed use discounts. You may be familiar with this from some other GCP products. This is a way to pre-purchase commitments to the service, gives you additional savings. You can do these in a couple different year increments, and the longer your commitment, the more that you'll save off of the list price. We also launched support this summer for Redis 7. This is going to be the latest major open source version. With this launch came the added functionality of Redis functions. It's kind of a spiritual successor to Redis Lua scripts. And we also made significant performance gains for TLS. So when you're comparing against TLS on Redis 6 or older Memorystore instances, you're going to see significantly lower latency and significantly higher throughput. So if you are using TLS on Memorystore, we strongly recommend upgrading to Redis 7. You're going to get the best possible experience with no added cost. Then the last one, AXT and DRZ. These are access transparency and data residency. This is going to give you audit logging of any access events to your instance, as well as some data locality guarantees as for the residency of data that you store within your Memorystore instance. These are key features to help unlock Memorystore in use cases in some of the more regulated industries. So we've been seeing more and more customers in this regulated space who are now able to adopt the service. So let's talk about Memorystore for Redis cluster, which is now available in preview. So what does Memorystore for Redis cluster give you? It gives you consistent performance at scale. We've got a UI shot on the left here. When you deploy a Memorystore for Redis cluster, you choose a region, a shard count, and the number of replicas per shard. And when you do this, you get an open source Redis cluster managed for you. The fact that we support the open source Redis cluster protocol means a couple different things. One, you're not going to need to perform any type of expensive application rewrites. And two, your migration to the service is going to be very simple. As you do this, the benefits of this horizontally scalable sharded deployment, you can deploy up to 250 shards for a given cluster. And this means multiple terabytes of key space and memory footprint associated with an instance, over 3 terabytes. When you do this, you also are able to scale in and out while the cluster is online. And as you scale in and out, you basically can size to your needs, and we will automatically rebalance the keys for you. So imagine you provision a cluster of 100 shards for whatever your data needs were yesterday. Over time, you might be expiring keys. You don't need that full 100 shards anymore. You can shrink that cluster to whatever size you need now, and we will automatically rebalance keys from the nodes that you're removing. In addition to this, as you scale out, each additional shard is going to give you more throughput for your cluster so you can continue to scale with your traffic needs. And so what does this do? This really takes Memorystore to new heights in our minds. So over the past few years, we've heard your concerns about the Memorystore for Redis service, which maybe meets the scale requirements that you have today, but it doesn't meet the scale requirements that you might have tomorrow based on how you expect your application or workload to grow over time. And so with the new service, Memorystore for Redis cluster, we're seeing a 60 times improvement in total throughput that can be supported by an instance, and a 10 times improvement in the amount of data that is supported by a single instance as well. And so we see tons of headroom to scale here. Again, you can also scale in and out as needed, so you can pay as you go. And you can pay for the size of the cluster that you need. As you scale in and out, you're going to get consistent and predictable performance based on the shard count associated with your instance. And what we're hearing from customers is that they're starting to consider taking their many smaller Memorystore for Redis instances that exist today on the standalone service, taking and consolidating these instances into one large cluster. And they're going to be able to realize huge cost savings from doing this while also giving themselves all of this additional headroom to scale in the future.
And one of the things I alluded to earlier was the high availability. So with Memorystore for Redis cluster, this is super easy. When you provision a cluster, we make sure to put the primaries in different zones. When you add replicas, which is a single click of a button, we make sure the replicas are in a different zone than the primary. So you can get 4 nines SLA extremely easily. And with all that as well, if there's a VM failure, or even if there's a zonal failure, the failover is automatic and fast to the replica. So rather than having to do this yourself on GCE, Memorystore for Redis cluster just makes this super, super easy. I'll also mention we're integrated with the best of Google Cloud. So we're launching with support for Private Service Connect, or PSC, which means that you can have your client in your VPC, and you can connect to Memorystore in the Google VPC, and your traffic never leaves the cloud. It's easy to provision these clusters, one-click automation again. And we also addressed one of the previous issues with IP address allocation. So even if you have 250 shards, you only need 2 IP addresses for your cluster. So a lot of quality of life improvements here with PSC. And then of course we're integrated, I think Matt mentioned some of these, we're integrated with security and monitoring. So you get IAM out of the box, you can centrally manage. You have Redis auth, TLS, audit logging, which you mentioned. And last, of course, cloud monitoring. So it's easy to set up monitoring on your cluster. You monitor, is the cluster too big? Is the cluster running too hot? Maybe I need to add shards. Maybe I need to remove shards. And again, that's really all about making sure you're spending the right amount of money. And now, this is the end of our presentation. We're going to bring on Animesh Chaturvedi from Palo Alto Networks, where he's a distinguished engineer.
Hey, Kyle.
Good to have you.
Hi, everyone. My name is Animesh Chaturvedi. I'm representing Palo Alto Networks here. So Palo Alto Networks is a global cybersecurity leader. We deliver innovations which enable secure digital transformations. Our mission is to be cybersecurity partner of choice. And we deliver basically these transformations with our best-of-breed platforms, world-class threat intel, and expert services, which bring to the table what's next in cybersecurity. And Cortex Data Lake is one such platform, which is the focus of our presentation today, and I'm going to talk about it.
So Animesh, prior to this preview launch that we're talking about today, we had a smaller private preview for a few select customers like yourself to try out the product early. You had a chance during that period. How did that go?
Well, it was awesome, and I was very impressed with the results. I was looking for basically 3 key things. First is simplicity. So it was very easy to deploy a new cluster, add and remove shards as needed. Performance and scalability. As I added more shard, the performance basically grew proportionately. And in terms of as a managed service, basically we do not have to worry about the deployment side and operations of it. We don't need to have Redis expertise in-house. And then it also integrates very well with various Google ecosystem like IAM, which makes it easy to adopt.
Okay, so it sounds like testing during private preview went well. Now that we're announcing public preview and expanding like this, do you plan to adopt Redis cluster?
Yes, certainly. So we have a number of microservices which constitute this Cortex Data Lake. Many of them use their own private deployment of Memorystore. Some of them are sort of over-provisioned, and we have some challenges with consistency in terms of security, as well as in terms of like the compliance and other aspects of it. By consolidating all of these smaller clusters, smaller deployments into managed cluster, I expect to save cost as well as get much better SLA. I think with our Redis managed cluster, we get 4 nines of SLA. So we are really looking forward to it.
Yes, awesome. So now let's dive deeper into how Animesh is using Memorystore today in his production use case of Cortex Data Lake, or CDL.
All right, so this is basically a classical Memorystore use case as a caching for our application. Cortex Data Lake is a very large-scale data platform which basically processes data that comes from various Palo Alto firewalls and security applications. To dig a little bit deeper, basically firewalls are processing traffic in a given enterprise coming in and out. And as they process this traffic, they apply security policies. The application of the security policy on that traffic generate huge amount of data. The second service that Palo Alto has is network connectivity as a service. This is basically known as Prisma Access, and the platform is called Secure Access Service Edge. This is where we connect users to applications. These applications can be in like a third-party SaaS provider or on-prem, and we also connect users to internet via this secure gateway. So now this basically also generates huge amount of data. And then there are many other Palo Alto applications which also produce events to this data platform. So the amount of data that we receive is insane. You can imagine there are thousands of customers with many thousands of firewall deployments. They are generating huge amount of data, and as such, we need a data platform, a robust data platform which can ingest and process up to 1 trillion events per day.
So it does sound like a great use case for Redis, but I'm sure a lot of the audience knows as well that there's many different options for Redis on Google Cloud. What led you to choose Memorystore?
So, of course, there are many options available. You can roll up your sleeves, deploy Redis on GCE or GKE, or use a third-party, one of the third-party providers of Redis on Google Cloud. But we went with GCP. First of all, we have a great partnership with Google. And being a managed service, we do not have to worry about like when you deploy anything in the cloud, you have to expect that the underlying node on which your workload is running at some point will get recycled out or patched. And so that's something as a managed service is abstracted from us. The simplicity and the performance and scale, all that we get from Memorystore, basically we can focus on our business and rely on Google for the operations of this critical service for us.
Nice. Now let's deep dive into the CDL architecture itself.
All right, so CDL, as I mentioned, is a very large-scale security data platform. We leverage a number of Google Cloud services. It's a microservice-based environment, so we use Google GKE quite a bit. GKE gives us a lot of auto-scaling and resiliency. We use Anthos Service Mesh. This is the service mesh that basically helps us manage various microservices. We also use Anthos Service Mesh as an API gateway, and we use various Google data stores like BigQuery, Cloud SQL, Bigtable, etc., and of course Memorystore to speed things up when we query these various data stores. All right, so in terms of Memorystore, we have a number of different deployments for various microservices. I'll group them into 4 categories. First is ingestion service. Then we have the control plane. And then the third one is our data processing service. And fourth is the query service. Next slide. So from an ingestion perspective, from a onboarding workflow, a customer basically goes to Palo Alto Networks portal. They create a virtual data lake for themselves in a particular region. Then they associate their Palo Alto applications or firewalls with the particular virtual data lake that they have provisioned. At this point, firewalls connect to a service asking for where should we send data. We give them a unique FQDN for that virtual data lake. The firewall connects to this ingestion service. Ingestion service is a very large-scale service running in GKE. And GKE gives us auto scale and resiliency. Our daytime to nighttime traffic is typically, daytime is almost twice as nighttime. So auto scaling is very important for us to basically scale down and save cost, as well as we get few spikes. So we want to make sure we are able to address those spikes. So GKE basically gives us all of that. And with this, basically, because we are running this data pipeline for many thousands of customers, this is very large scale, and we have to process up to 1 trillion events per day.
So you have this GKE service that's auto-scaling for the event load that you have coming in. You're enriching that data with the cache data that's in Memorystore, 1 trillion events per day. How do you manage that scale past that point?
So very good question. So in order to manage such a large data service, you need a very robust control plane. The robust control plane basically needs to abstract various data pipeline components, the firewall metadata, the connectivity for various firewalls, making sure that they are all able to send data. And in the customer metadata, we are able to enrich the logs with contextual data from customer's environment. All of this metadata is kept in Cloud SQL, and we put Memorystore in front to speed up the pipeline, thereby reducing our compute as well as making our pipeline a lot more efficient.
Right, so the logical next question might be, what if you didn't have Memorystore to speed things up? What if you had to rely only on the database behind?
All right, so if Memorystore was not there, then our pipeline would have to basically make metadata query calls to the underlying SQL store, which typically is much higher latency. Now, with that higher latency, the throughput of per parallelization would be much smaller, but we still need to maintain that trillion events per day kind of speed. So in order to do that, we would have to increase our parallelization. That means we have to bring in a lot more compute, and that means the cost of the pipeline would be much higher.
Right, so by using Memorystore, you can both speed up the application and actually save money because you need fewer resources elsewhere.
That's correct. And the third service is the data processing service. We use Kafka as our messaging layer. We have put lots of innovation and tooling around Kafka to work at our scale. We are able to, on a spike, we are able to increase partitions. We are able to add our retired topics. So when we have to, let's say, reduce partition, we'll transition to a new topic and then clean out the old topic. We are able to seamlessly add new clusters as our demand grows. And all of this information is kept in basically the metadata service or the control plane. The control plane knows where, for a given customer, which Kafka topic and cluster the data resides in. The control plane also knows which data store the data should be transferred over to. So to the right of the Kafka cluster is our various workloads. The workload up top is our persistent job. This reads data from Kafka. It talks to the control plane via the Memorystore to look up which Kafka topic or cluster to read data from, and then looks up the control plane again to figure out what tenant project and which data set should we be writing that data to. At the bottom are various Palo Alto streaming applications. These are real-time applications, reading data from Kafka, applying filtering and enrichment, and then sending the matched data streams to the application endpoints. And the fourth and the final service is the query service. Query service provides the abstraction for underlying data store. When a query from a UI or API comes in, it looks up the control plane with the Memorystore in front of it as to figure out where the data for that particular query resides in our data warehouse. It runs those query jobs, executes the query jobs, caches the results, and presents it to the UI or API as needed. Now, in this case, also, you can see we are using Memorystore. So net-net, we have Memorystore sprinkled across all of our services, and this helps us make our pipeline much more efficient and scalable and cost-effective.
Great. Well, thanks, everybody. We're closing now. So that's all we had for today. Just to recap, we're super excited about the Memorystore for Redis cluster launch. So please give that a try. That's now in public preview. And we have our emails up here. So if you have questions or feedback, please feel free to reach out to us directly.